Today in geometry, we are looking at Envision, section 10.1, arcs and sectors. Our central question for today, how are arc length and sector area related to circumference and area of a circle? After today, you should be able to find arc length and sector area of a circle and use them to solve problems. So let's start out with some vocabulary again. A central angle of a circle, so a central angle of a circle, is an angle formed by two radii, that's the plural of radius, with the vertex at the center of the circle. A central angle creates two intercepted arcs. This is intercepted. An intercepted arc is the part of a circle that lies between two segments, rays, or lines that intersect a circle. A minor arc of a circle is an arc that is smaller than a semicircle. A major arc of a circle is an arc that is larger than a semicircle, or 180 degrees. A minor arc is named with 2 letters, while a major arc is named with 3 letters. The degree measure of an arc is equal to the measure of its corresponding central angle. And remember that there are 360 degrees in a circle. So if we look at this first circle P, we notice that KL, arc KL, is marked congruent to arc JK. So I would say that the measure of arc JK is equal to the measure of arc KL. The measure of arc JM would equal the measure of angle JPM, and angle JPK is congruent to angle KPL. So now if we come over here and we look at circle P, a minor arc, one that's less than 180 degrees, would be arc AB. A major arc, one that's greater than 180 degrees, would be arc ACB. So now we're going to use circle P and circle W to answer these questions. So number 1, find the measure of arc AB. Its central angle is 95, so that arc is also 95 degrees. Number 2, find the measure of arc ACB. That's the only other arc in that circle. The circle is 360 degrees, so 360 minus 95 gets us 265 degrees. Now we're going to go to circle W, find the measure of arc XZ. XZ's central angle is 115, so this is also 115 degrees. Find the measure of arc XYZ. Again, 360 minus 115 gets us 245 degrees. So now we're going to talk about relating arc length to circumference. The arc length is a fraction of the circumference. The measure of an arc is a fraction of 360 degrees. We can use a proportion to represent the relationship between arc length, which is S, the radius R, and arc measure, which is N. So in words, that would be arc length divided by the circumference is equal to the arc measure divided by 360. If we put those variables in the place, arc length is now S divided by circumference, which is 2 pi r, equals, instead of arc measure, that's N divided by 360. Cross multiply and solve this for arc length for S, so we would get that the arc length, so again, this is arc length, is equal to N divided by 360 times 2 pi r. Now, besides degrees, angles can also be measured in radians. The radian is equal to the measure of a central angle that intercepts an arc with equal length to the radius of the circle. Circumference is equal to 2 pi r, which is 2 pi arcs of length r. Since each arc of length r corresponds to 1 radian, there are 2 pi radians in each circle, so 2 pi radians is equivalent to 360 degrees. So if we put that in the formula, we see that
We are currently experiencing.
we see that a radian is equal to the measure of a central angle that intercepts an arc with equal length to the radius of the circle. So arc length over circumference is equal to arc measure in radians of 2 pi. So again, if we cross multiply and solve that, we get that S, the arc length, is equal to theta times r. So the Greek letter theta represents radians. Let me draw that letter a little bit better. So Greek letter theta represents radians. So anytime you see that, you know that we are talking about radians. Again, n equals arc measure.
Thank you.
And n is arc measure. And S is the arc length. So these two right here show us our formulas. If the central angle is in degrees, our arc length is equal to the arc measure over 360 times 2 pi r. If the central angle is measured in radians, our arc length is equal to theta times the radius. So let's look at some examples. In a circle with radius 4, what is the length of an arc that has a measure of 80? Round to the nearest tenth. So here we are in degrees, so we're going to say S is equal to our arc measure 80 over 360 times 2 pi times my radius is 4. So we're going to put all of that in our calculator. So 80 divided by 360 times 8 pi. We're going to round to the nearest tenth, so that is approximately 5.6. So the arc length is approximately 5.6. They did not give me units, so I don't have units to put there. Number 2, in a circle with radius 6, what is the length of an arc that has a measure of pi radians? Again, round to the nearest tenth. So this time we're going to use the S equals theta times pi. So here, theta times radius. So here my theta is pi, my radius is 6. So I'm going to type that in my calculator, 6 times pi, and I get approximately 18.8. So now they give us this picture of circle P, and wants to know what is the length of arc AD. Express your answer in terms of pi. So the length of arc AD, first I need to find my arc measure, which is n. So the length of the arc measure AD, remember that the entire circle is 360. So 360 minus the other angles in there, 104 minus 43 minus 73 is equal to 140 degrees. Now that I have my arc measure, I can find my arc length, remember, which is S. So I'd say S is equal to my arc measure, 140 over 360, times 2 pi times my radius. Here the radius is 4. They tell me to leave my answer in terms of pi, so that means we want to reduce everything. So I see that my zeros will cancel out. So really right now I have 14 over 36 times 8 pi. So I'm going to look to see what do these have in common. Okay. So 8 and 36, what's the biggest number that 8 and 36 have in common? They both have a 4 in common. So if I take a 4 out of 8 and 36, still have the 14. So 4 goes into 36 9 times. 4 goes into 8 twice, so 2 pi on top. So now if I multiply 14 times 2, I get 28 over 9 pi. So that is my answer. So anytime they ask me in terms of pi, that means no decimals. Okay. Number 4 says use circle Q, express the answers in terms of pi. So again, no decimals. What is the length of arc JK? So JK. So let's find the measure of arc JK. That is the same as my angle in there, which is 3/4 pi. So that's my n. So the arc length, S, equals 3/4 pi times pi times 5. Oh, sorry. I got an extra pi in there. 3/4 pi, that's my theta, times my radius, which is 5. So on top, 5 times 3 is 15 over 4. They don't have anything in common, and then pi. So my answer, 15/4 pi. Number 5, what is the length of HK? So HK, first I need to find that arc measure. Since it's in radians, remember that instead of 360, it's 2 pi minus 1/3 pi minus 3/4 pi. So we want to get a common denominator. That common denominator is going to be 12. So here, multiply the top by 12. So 2 times 12 is 24. 1 times, let's see, 4 is minus 4. Here I'd have to multiply by 3, so minus 9, all that pi. So 24 minus 4 is 20. 20 minus 9 gets me 11 pi over 12. So now I can find my arc length. S is my theta, 11 pi over 12, times my radius, which is still 5. So multiply, 11 times 5 is 55 over 12 pi. 55 and 12 don't have anything in common, so I can't reduce. All right, next page. A sector of a circle is the region bounded by 2 radii and the intercepted arc. In general, the area of a sector is A equals N, so the arc measure divided by 360 times pi r squared, where N is the measure of the intercepted arc, and the area of each shaded sector. So our formula, A equals, so if this is 78, okay, that is the intercepted arc, so 78 over 360 times pi times my radius, 10 squared. And again, we're going to leave this in terms of pi. So 10 squared is 100. So on top here, I have 7,800 over 360 pi. I'm going to reduce, so those zeros cancel. So I have 780 and 36. They both, let's see, have a 12 in common. So if I do 780 divided by 12, I get 65 pi. 36 divided by 12 is 3. They gave me units here, centimeters. I found area, so it's squared. So my answer is 65/3 pi square centimeters. So number 2, my area, 165 over 360 times pi times 3 squared. So again, 3 squared is 9. 9 times 165, I get 1485 on top over 360 times pi. Let's see, I believe those both have a 5. For the sake of divide everything by 5. So 1485 divided by 5 gets me 297. And then 360 divided by 5 gets us 72. We could keep going though. So let's see, those both have a 9 in common. So take a 9 out of everything and I get 33 over 8 pi. This time they didn't give me anything, so I'm just going to say square units. And number 3, my area would be 59 divided by 360 times pi times 10 squared. So again, 10 squared is 100, so I get 5,900 over 360 pi. Reduce, so those zeros cancel, so 590 and 36. Biggest number they're going to have in common is a 2, so take a 2 out of everything, and I get 295 over 18 pi, again, square units. So now we're going to talk about a segment. of a circle. That is the part of a circle bounded by an arc and its segment joining its endpoint. So now we're going to find the area of the shaded region, okay? So the area of a segment is going to equal the area of the sector minus the area of the triangle that it is created. So let's first find the area of the sector, which is what we were just doing up there. So 60 over 360 times pi times 8 squared. So here I see that that's going to cancel. 6 goes in 36 6 times. So I have 64/6 pi, which will reduce to 32/3 pi. And now we're going to find the area of the triangle. I pull this triangle out. This is 8. This is 8 because this is also a radius. That started out being 60. I need to find my height, so that's my altitude that I dropped down. So now I have a 30, 60, 90 triangle. So I know that my height, that is my long leg. My x down here is my short leg. My hypotenuse is 8. My short leg is 4. My long leg is 4 square roots of 3. So remember, the formula for area of a triangle is 1/2 base times height. This entire base would be 8. So 1/2, 8 times my height, 4 square roots of 3. So I end up with 16 square roots of 3 here. So the area of my segment is going to equal 32/3 pi minus 16 square roots of 3. We're going to go ahead and put that in our calculator. And when we do, we get that approximately 5.8 square centimeters. Let's do another one of those. So again, we're first going to find the area of the sector. This is marked 90, so that's going to be 90 over 360 times pi times 10 squared. Those cancel. My 9 goes into my 36 4 times. So I have 100/4 pi, which is 25 pi. So now I need the area of the triangle. I have a right triangle here. Sorry, let me go to that. Where both of these sides are 10 and 10. Remember, in a right triangle, okay, both legs are my base and my height. So the area of this triangle is 1/2, 10 times 10. So 1/2 of 100 is 50. So the area of the segment is equal to 25 pi minus 50. Again, I'm going to put that in my calculator, and I get approximately 28.5 square feet. All right, last page, number 3. So let's find the area of the sector. Again, that's going to be 144 divided by 360 times pi times 5 squared. So 144 over 360, that's going to reduce to 2/5. Pi times 25. 5 goes in there, 5, so I get 10 pi. The area of my triangle. So now I'm going to pull out this triangle. I know that this started out being 144. These are both 5. When I drop my altitude down, that split this in half, so now it's 72 degrees. I want my height and my base. So that here we're going to have to do SOHCAHTOA. So if I do the cosine of 72, it's going to be h over 5. When I solve that, I'm going to find that my height is approximately 1.55. So now I would have to do the sine of 72 equals my base over 5. So I would find that my base is approximately 4.76. Remember, I need to multiply that by 2 to get the entire base, so that's going to be approximately 9.52. So the area of my triangle, 1/2 the base, 9.52, times the height, 1.55, is approximately 7.378. So the area of this segment is equal to 10 pi minus 7.378, which is approximately 24.04 square meters. Now let's look at some word problems. Nash uses circular corkboards to make 18 coasters to sell at a craft fair. He paints one side of each coaster with special paint. Each jar of paint covers 200 square inches. Will one jar of paint be enough to paint all the coasters? So this gives me the picture of the coaster that we've pulled out. Okay, so let's find the area of that coaster. I see that my angle is 72 over 360 times pi times my radius. The diameter was 8, so that means that my radius is 4 squared. When I simplify and everything here, we end up with 16/5 pi, which is approximately 10 square inches. I have 200 square inches that it will cover. So 200 divided by 10 gets me approximately 20 coasters that I could cover with that paint. I'm looking to make 18 coasters. So yes, he has enough paint to cover 18 coasters. Okay. All right, the last question. He puts decorative tape around the edge of each coaster. How much tape does he need for each coaster? So that's asking for the perimeter, right? So if this is our coaster, we know that this was 72, this was 4, this was 4. Okay. We have 2 radii and an arc to get our perimeter. So the perimeter is 4 plus 4, my radius. Now the arc is going to be 72 over 360 times 2 pi times my radius, which is 4. So 4 plus 4 is 8. Plus when we multiply and simplify all this, we get 8/5 pi. We're going to add those together, so we're going to put that in our calculator. Approximately 13.03 inches of tape is what we would need there. All right, so that wraps up section 10.1. Our homework assignment will be Envision worksheet 10.1, numbers 16 through 26.